So in this video we will be talking about the technique called DLL harrowing. So it's similar to the process harrowing. So in this we will load the legitimate DLL into the process, and then we will hollow out the text section with our shellcode, and then at that shellcode we will create the thread to run the shellcode. So first let's get the handle to this process. So there is an API called Steam API.dll, which is a legitimate Steam DLL. So let's say string DLL path is equals to the path, we will be using the open process function to get the handle, and then we will allocate some memory to write this string. So why we need to write this string? Because we will be using the function load library to load kernel32.dll, and then finding the load library function, and then we will run the function load library with this parameter. So with this as a parameter, so the DLL gets loaded in the remote process using create remote thread. So first let's get the handle. So open process, so desired access is process all access. So I have just copied from this R, and the process ID, so let's say int PID is equals to 0 for now, PID, and in return we will get the proc handle. Now we are going to allocate some memory, that is this one. We can also convert this into bytes. Byte DLL path is equals to encoding dot ASCII dot get bytes and DLL path. So let's allocate some memory using virtual alloc-x. This is proc handle, and the base address we will give 0, so the operating system will allocate memory region for us, and the size is this one, byte DLL path dot size. Dot length, and allocation type is mem commit and reserve. Protection type is read write execute. You don't need execute because we are storing only the string at that, so I think read write should be fine. So we will get the base address. So at this base address we are going to write using write process memory proc handle, and the base address is this base address, and the byte array is byte DLL path, and the size is byte DLL path dot length, and out bytes written. So let's create a variable bytes written is equals to 0, and we can say out bytes written. So the this string will be written into the process memory, remote process memory. Now what we are going to do is we need to load library of the kernel 32 the DLL. So this will load the specified DLL into the memory. So let's say DLL handle, so we will get the handle to this DLL, and in this DLL we need to find the function that is load library A, and the function name is load library A, and we will get the function's address. Function address is equals to this one. Now we have the function address and we have the string address, so we can create the thread to execute this load library with the argument as this one DLL, so that DLL will be loaded. So it's nothing much, it's a legitimate DLL. Later we will replace the text section with the shellcode. So create remote thread proc handle and thread attributes null, stack size 0, start address is this function address, and the function parameter is the base address, and the creation flags 0, so the thread will start immediately. And the return type is the thread handle, and out thread ID. So let's put the breakpoint here and let's start the notepad. So there is this notepad, double click on this and go to modules. You will see there is no steam API.dll, so you can click on this name to sort according to the alphabetical order. So there is no steam API. Now let's we can also print base address dot toString. So let's run this one. So we got some error. Okay, because of the PID, so we did not give the correct process ID. So copy this one and paste here. So let's put the breakpoint before this remote thread function, and now we get the base address. So read write, right? So we can do like this. 236 9AF00. E. So this one I guess. So here we can see the DLL string. Now let's close this and let's go and run this one. Now we should see the DLL if it's loaded or not. Go to modules, and here we can see steam API DLL. So let's close this one. Now what we are going to do is so we are going to find the loaded DLL's names and their base addresses. So we can do that using the function create 232 snapshot. So we have seen this in the previous videos, how to load that how to find the DLL's name and their base addresses. So it will take the snapshot of the processes or the modules, threads, etc. at that point of time. So if you run this after 10 minutes, you may get different values. So the first one is the flags. What type of information do you want? So we want all the information, and the process ID, the second parameter. So now create. So I have already declared this because I don't want to waste your time by declaring this. So you can go to pinwork and copy this. So these functions are there. So 1824. So 1248. And then we need to pass the PID. So we will get the snap handle, the snapshots handle. So let's call this as snapshot handle. So this snapshot handle should be passed to this module first function. So this gives the information about the first module. So here you can see the first parameter is the snapshot handle, and second parameter is the string we will get to this one. So a pointer to this structure, module 32 structure. Here we will have the size and the module ID, process ID it belongs to, and here we have the base address, and here H module. We will also have the handle to this module, and also this module path, and that module name, and that module's absolute path. So this structure can be copied from pinwork. So I have already copied this one. So here you can see, before copying I thought it was a by value array, so it's not, by value string. So entire array will be converted into the string, so you don't need to worry about that. So let's call this one module 32 first snapshot handle. So we will be creating a new module entry 32, let's say new module entry 32, and we need to define the size. So it will take the information in this structure, and we need to declare the size. So me.size is equals to marshal.size of type of module entry 32. We got some error, so it is uint and this one is int. So now we can pass this as reference me. Now I can print me dot module sz module. So sz module is this one name. You can also rename this one so that we can read clearly. So what we can do is we can use the whenever this function is called, the module 32 next, so it will be like a linked list, it will move on to the next one. So what we can do is while me dot process id not is equals to 0, we will be calling module 32 next snapshot handle reference me. So okay, this should do fine, I guess. Now let's go and print these module names. So again, once again, start the notepad and copy the process ID, paste here. So let's go and run this one. So at this point, so let's also run this remote thread. At this point we should have the Steam API DLL loaded into the process. So here we have the Steam API DLL. Now let's go and run this one. We are getting some errors, so let's stop this and so let's say me.sz module So since the API Steam API DLL already loaded, so we can just comment out this one. Comment out up to this. So since we are getting error, so let's run this one. Okay, we got this DLLs, so fine. And we can also print the me dot module base address dot to string. So let's go and run this, and we should have every DLL's base address. So it's not a sorted error. So what we can do is, if me.sz module is equals to dot contains Steam, and then only we are going to print this one. And here we can see we got the one DLL with the name Steam in it and the base address. Now at this base address there is a DLL, and what we need to do is we need to find the offset of this entry point. So I have this function, we have seen this in the PE parsing videos. So this is similar where we have found the size of header offset. So here it will be 80, I guess, and I have changed this to 40. So PE offset plus 40 bytes gives you the entry point. So you can just change this 40 and you will get the entry point. So we can do this one. We can create let's say we need to store this value base address. DLL base is equals to 0 and DLL base is equals to, so we are saving this to a variable DLL base. So we can put a check if int pointer dot size is equals to 8, then DLL base is equals to me dot base address dot to int 64, else DLL base is equals to me dot base address dot to int 32. So you no need to worry about changing the 64 to 32 when you compare for 32-bit architecture. So we have the DLL base. All we need to find is the entry point offset. So we can get image entry point of. So it takes the byte array and it gives you the int entry point. So whenever you can add this one, DLL base and entry point, so that gives you the first instruction. So we need to first write the this the actual content. So I have already copied this one, the previous payload, that is calculator payload. So we are going to write into that base address DLL base and entry point. Proc handle, and the base address is DLL base plus entry point, and the buffer is our calculator payload, and the size is payload dot length, and out bytes return. Okay, let's delete this one. So we are writing that our shellcode into that DLL base plus entry point. Now what we can do is we can create a remote thread at that address where our shellcode resides. So we can just copy this one, creation flags, start immediately, out thread ID. So I think we have missed something. So function parameter. So okay, I think we are good to go. So let's put the breakpoint at this. Let's also print DLL base plus entry point dot toString. So let's close this one. So let's run this. So we have this address. 7ff. So here we can see the DLL, so we can search for our Steam API DLL. Okay, here we have the DLL's memory 7ff, 8f, 8f and 4a. So 7ff, 8f, 4a and 70,000, I guess, this one. So if I go and double click this, not this one. Oh yes, at this one we have at the entry point we should have the shellcode. So we got some error, so let's see that. Okay, so we need to read this file dot read all bytes. So we are actually passing the string instead of reading the contents. DLL content. So let's copy the process ID and now let's put the breakpoint at this write process memory. So let's run this. Oh, we have this address. So previously this is the base of this DLL base. So I guess our after this point it should write correctly. So let's go and run this. So if I go and run this, our calculator should pop up, and here we can see the calculator. So that's about the DLL harrowing. So we loaded the DLL and then we hollowed out the text section and replaced that with shellcode. And we also used this create to help 30 snapshot, which is very helpful in finding the base address and the DLL's name at the same time. And then later we created the thread at that shellcode address.